So in this video, we're going to continue to show you how to solve exponential equations. We'll start with the very basic one, like you have 4 to the power of x plus 1 equals 16, for example. So, well, to get rid of an exponent, we can just take logarithm of both sides. So we can do log to base 4 of 4 to the power of x plus 1 equals log to base 4 of 16. Now the right side, log to base 4 of 16 is 2, because 4 to the power of 2 is 16. And the left side is just x plus 1, because I can write that log base 4 of 4 to the power of x plus 1 as x plus 1, bring it to the front of the log, and log base 4 of 4, which is 1. Log base 4 of 4 is 1, so x times 1 is just x plus 1. Okay, so instead of doing all of this, I can just use the inverse property to recognize that whenever I take a log of a number to the same base, that's going to eventually cancel out, so x plus 1 is left. So now what is left is just to solve this simple algebra 1 equation now. So subtract 1 from both sides, x equals 1. Alright, that's all well and good until we come to a problem like this one. What if I gave you 4 to the power of n equals 34? Where if I try to take logarithm of both sides, so up to base 4, log base 4 for n, and then log base 4 of 34, I won't be able to evaluate the right side just like that, because 4 to what power make 34? Let's try. 4 to first power is 4. 4 to second power is 16. 4 to the third power is 64. So 34 is somewhere here. So the answer I'm looking for is between 2 and 3. So I cannot take log base 4 like that. So rather, this is what I would do to answer this question. This is what I would do. I would take logarithm to base 10 of both sides. So whenever there's no direct relationship between this number and this number, I will take log base 10 of both sides. You know that when it's log base 10 is implied, the 10 is implied, it's not written. So log base 10 of 34 and log base 10 of the left side. So that's our first step. Whenever there's no direct relationship between this number and this number, we take log base 10 of both sides. Now I can write this as n log base 10 of 4. Okay, I don't want to write a 10, so we don't need to write a 10, just log base 4 like that, equals log 34. Log 34, log base 10 of 34. Now I can divide both sides by log base 10 of 4 to get n by itself. This will cancel, so n equals log base 10 of 34 divided by log base 10 of 4. Now it's possible to use a calculator to estimate the value of log base 34 and then log base 4 and divide the answer. So we can use a graphing calculator. You can also use a web calculator like the Google calculator. I will use the Google calculator here. So here is the Google calculator. Let's see if I can get it to center here. Let's see. Trying to make it to center. Okay, I think it's here. You have it. Okay. So now I can do log 34 divided by log 4. Log 4. Close parenthesis. and the answer is approximately 2.5437 . So if I round this to the nearest hundredth, so it will be approximately 2.54. So let's go back to our screen and get this out of the way. All right, back to our screen. So this is approximately 2.54 if I round to the nearest hundredths. All right, so but that's for just a simple case in which, there's nothing else, only one step. You might have another situation that is beyond one step, like, for example, before we get to multi-step, let's look at what if the base is E. All right, if the base is E, well, we're going to recognize that we're going to take natural logarithm of both sides because the base is E. So this one is quite easy. All we need to do is to do natural logarithm of both sides. Okay. You know that natural logarithm is like log base E. So it's the same thing as natural logarithm. That's why we're using natural logarithm to get rid of the E. So B is just ln 71. I can use a graphing calculator. I can use a web calculator. Let's try to use a web calculator to do that. So try to do the same thing here. Clear entry, and then natural logarithm of 71 is approximately 4.26 if I round it to the nearest hundredth. Okay, so go back to our page. So this is 4.26, approximately 4.26. All right, there are other situations that need calculator, like, for example, this. Well, I need to get rid of this 4 first. So I need to add 4 to both sides. So 10 to the power of x minus 4 equals 90. And then I take log base 10 of both sides. Log base 10 of 10 to the power of x minus 4. Log base 10 of 90. The left side using inverse property is just x minus 4. And then we are left with only log of 90. Log base 10 of 90. So we can use calculator to do that. Let's use our calculator to do that. And so we have log of 90. Get rid of this 90. Log of 90 is approximately 1.95. So now I go back to my screen. 1.95. So this is x minus 4 is approximately 1.94, I think. Let me just see. 1.95. Sorry about that. 1.95. So, and then I add 4 to both sides. X equals approximately 5.95. So basically, that's what you do if you have different situations like that. I hope this helps a little bit.